A lot of strength coaches are conducting counter movement jumps on force plates with their athletes these days, but collecting that data and actually understanding what's happening in the jump itself aren't the same thing. Because software will spit out a ton of metrics, like something like 80 for a counter movement jump, but selecting which ones to use and what's actually important and going to move the needle comes back to understanding the force time tracing of an actual counter movement jump. This is the force time tracing of a counter movement jump, and if you don't know how to break this down into sections and the phases, then you might not be able to properly interpret your data. But once you understand this properly, you can go beyond just reporting the numbers that a software spits out to you, and you can actually think about and break down how an athlete is producing the force or actually conducting the jump themselves. So in this video, I'm going to walk you through the 6 phases of a counter movement jump so that you can understand how somebody is jumping beyond what just the metrics tell you. So before we break down the phases of the jump, we actually have to understand what a force plate is doing to provide us with the metrics that we're getting. And in the simplest terms, a force plate is measuring the force that is applied to the ground. So it's just measuring force over a given period of time, and it's doing this at very high sampling rates, usually 1,000 hertz, so 1,000 measurements per second. So really, a force plate isn't telling you how high somebody jumps. It's measuring the force that's applied into the ground by the person that is jumping, and then we apply some mathematics to it to be able to get us how high somebody jumps and all of the other metrics that come out of a force plate reading. But it all comes back to this, and we can break down the curve into phases so we can better understand the jump itself and the metrics that we're getting. So the first phase actually doesn't even look like it's a real phase, but it's right here to the left. And it's our baseline phase. So what we're doing in the baseline is just getting a stable reading of what the person weighs from the force plates. So it's taking a 1 second time period here, averaging out the measurement of ground reaction forces and giving us the body weight of the person. And though it doesn't really look like anything's happening here, it's actually the most important part of a jump. Because if you don't get your baseline right, then all of the metrics that are derived down the line will be wrong as well. Everything is based off of this standing, stable body weight measurement. So if you can do one thing right in your procedures for a counter movement jump, is getting this baseline stable and accurate. Our next phase is the unweighting phase, which is the part of the jump where the force reading is below the stable baseline of the athlete. This point right here is the point of initiation of the jump, where the jump actually starts and the person starts moving downward to initiate their counter movement jump. The force is below the person's body weight because the person is accelerating downwards in a controlled fall. The slope of the line from here to here can give us some insights into the way the person is initiating their drop. If this line is steep, it means that they're probably initiating quite fast and ready to drop in to their jump, which might be a more aggressive strategy. Meanwhile, if this line went more like this and maybe didn't go as deep and was a little bit more shallow in the slope, it might be a more conservative approach to initiating the jump, which might give you some indication of their confidence. So the unweighting phase really tells us how somebody's initiating the jump, and the amount that they unweight and the slope of the line can give us some insight into the strategy and confidence that they have going into the jump. Next, we go into the braking or the eccentric phase of the jump, depending on who you talk to. They call it different things. And that goes from when the force goes back above our baseline until it reaches its peak up here, which we'll call right here. So it's a relatively small phase, but it goes from the point where people start applying the brakes to when they're in the bottom position of their jump before they come back up. And in this phase, people are applying the brakes and decelerating. So they're no longer going faster as they go down. They're still moving downward, but they're applying force into the ground to try to decelerate their velocity. And this phase is generally what people will call slamming on the brakes, but it's not just an eccentric quad strength phase of a jump. It also requires coordination, stiffness, and control of the body, in addition to slamming on the brakes or decelerating their body when they go down. So in this phase, you might look at something like the eccentric impulse, the braking rate of force development, or the asymmetry in the eccentric impulse. The fourth phase of a counter movement jump is the propulsive phase or the concentric phase, depending on who you're talking to. And it's the phase from the bottom of where their center of mass is until toe off at the top of their jump. So it goes from this point down to here. So it's all through here. If we look at the curve itself, we're going from the base of the jump to they're starting to accelerate up or move up and the force starts to decrease. And then about 2/3 of the way up, they hit generally a second peak where force increases again before decreasing at takeoff. So there's usually a bimodal section of this where this second peak happens. So jump height itself is determined based on what happens in this concentric or propulsive phase, notably what is the concentric impulse, which is the area under the curve in this phase. And that's used to calculate our takeoff velocity, which then gives us our height. So what you might see is two athletes may have the same jump height, but this propulsive phase could look different, but they still end up with the same output at the end. A couple metrics to look at in this phase are propulsive impulse with the left and the right leg and the difference between them, the peak and mean power produced, and then obviously takeoff velocity, which is what feeds us into our jump height. Next up, we have our flight time, or flight phase, which there's actually no reading on the force plates in this point because the force plates are empty and the person's not on them, they're in the air. So the flight phase doesn't tell us anything on the force time curve necessarily, but it's still an important phase. So one thing that you can do is if you're recording your athlete, you can look back at the video and see if they're twisted in the air, if they're side flexed, if they're doing anything weird like that. You'll also see that some athletes will try to pull their legs up when they're about to land in an attempt to increase the amount of time that they're in the air. But because we're deriving the jump height from the concentric impulse, you actually can't really cheat the test by changing what you're doing in the air. So it's actually one of the reasons why a force plate is so important to have when you're objectively testing people's jump height, because you can't cheat the test. And then we go into phase number 6, which is the last phase, the landing phase, which is actually my favorite phase. I did my whole master's looking at the impact of lower body strength on the way that people land, especially after ACL injuries. So what we see on this is the person makes ground contact and we see this big spike to here, which is their peak force on landing, which is usually higher than the peak force eccentrically. And then the person kind of stabilizes themselves and then comes back to their baseline standing, which is the end of the jump. And this phase is really important because it gives us insight into how people are absorbing high energy landings and dissipating the force or decelerating their body. And in this case, we'd probably look at something like what the peak force is, the time to stabilization, so the time from ground contact to when they're back to standing and stable again at body weight, their landing rate of force development, and asymmetries in their landing impulses between left and right legs. And it's particularly important to look at your landing because that's generally when people get hurt, is in these high eccentric load events like landing. So if you think about a basketball player or volleyball player landing, a skier or snowboarder landing, that's generally when they're going to get hurt, especially ACL type injuries. So landing is a very important metric to also look at. So those are our 6 phases, from baseline through unweighting, the eccentric phase, the propulsive phase, flight, and then landing. And the key here is that no single phase tells us a whole story. We have to go back and we have to look at how things build over the course of a jump and see if something early on may have impacted something down the line. Similarly, no specific one metric that force plate software puts out is going to tell you the whole story of the jump. You have to take everything holistically and look at the big picture and how things are interacting with each other so that we get a better understanding of what's going on across the whole jump rather than focusing in on one metric or one phase. Because what we've seen time and time again is one athlete might have a very aggressive initiation of their jump, one might be a little bit more passive in their initiation, but they still end up with the same output metrics. So we need to be able to understand how they're getting there and then how to apply that to their training. If you're collecting data on force plates with your athletes, this here is the base foundation that should put you in a position to better utilize the data and build off of the metrics and what you're seeing from the force time tracing. If you want more breakdowns like this, I invite you to subscribe because this whole channel is about how to use this sports science information in practice with your athletes. We'll see you in the next one.